right, so this is our introduction lesson to decimal division. Some of us have done this more than others, but it's a good review. We're going to set up long division for these. So our first question says we're going to take 9.3 and divide by 2. So I'm going to color code this. I'm going to make the first number yellow and the second number orange. And then when we set up the long division, the second number is the one that I usually write down first. I switch the order because that's what we're dividing by. It goes on the outside. And then the 9.3 goes on the inside. You will want to write small in order to fit these into the space because some of these are going to go a little ways before they repeat. So I'm just going to color code. The number on the inside was the first number, and the number on the outside was the second number. And you don't have to color code in your notes, but for some people, this really helps. So I like to show it that way. All right, so we start this just like long division. So when I have my decimal point here, before I start, the one major difference is I'm going to bring that decimal up here. Everything else is going to be just like dividing by 93. We're just putting a decimal up here. So there would be a decimal in our answer. We're recording, so is this a good question? Okay.
2 goes in 9.
Okay, so he's just wanting to get us started. So 2 goes into 9 4 times. And that's going to go before the decimal point. It's super important that you keep things neat and lined up when you're doing long division. Okay, so then 4 times 2 is 8. I'll write that down here and subtract. 9 minus 8 is 1. And then we bring down the 3. So this is just like long division. And then I have to figure out how many times 2 will go into 13. So, Brian. 6 times. And because this 3 is after the decimal point, that 6 is going to go after the decimal point. And we'll take 6 times 2, which is 12, and we subtract and get 1. And we're going to keep going. When you have a decimal, you could put as many zeros after that 0.3 as you want, and it's still 0.3. 0.3 and 0.30 are the same thing, and we do that so that we have a number to bring down. So now, how many times will 2 go into 10? Shay? 5 times. And then 5 times 2 is 10, and we'll subtract. And we get 0 for the remainder. So we're going to keep going until we can't go any more with these. And so this is my final answer. I'll put a box on that. It's 4.65, 4 and 65 hundredths. Did you have a question?
Why do you have to do that last step, the 10 minus 10?
So that's to show that there's no remainder. It's just completing your long division. You're supposed to do that with long division. Anytime so that you're showing that there's no remainder and we're done. Okay? Another question?
Would you mark us off if we didn't do that?
Yes. You got to show your steps. So you always have to show all of your steps, so please go all the way to where you're stopping. It's not going to take you very long to write minus 10 equals 0. I feel like it's not even a whole second of your life, so you can do that. All right, so I'm going to color code the next one. The 8.1 I'm going to make yellow, and the 3 I'm going to make orange. And when I set up the long division, it's going to switch order. So the 3 goes on the outside of our division symbol, and the 8.1 is going to go on the inside. So I'll color code. This inside was what was on the beginning, and this is what was on the outside. And before you start, take this decimal point and bring it up. And any number that it's going into before the decimal point will go before the decimal point up here. Anything that's after that decimal point will go after. Question? Or do you just want to tell me how many times 3 goes into 8?
Well, it goes 3 times.
Okay, so 3 times 3 is 9. That's a little bit big. So what's 3 times 2? So think 3 plus 3.
9.
Is, somebody want to help me out? What's 3 times 2? 6. So we're going to put 2 up here and use 6. So we've got to be careful that we don't go over, but that was a good try. So 8 minus 6 is 2. And then your next step is to bring down the 1. And we can figure out how many times 3 goes into 21. That goes in evenly. How many times? 7. And since this 1 came from after the decimal point, it's important that the 7 comes after the decimal. And then, yes, you do need to write 7 times 3 is 21. Really quick, subtract it to make 0. It's not going to take you very long to finish that out. We're showing that we're done. There's no more to do because it came out 0. And we also ran out of numbers up here. Sometimes you can get a 0 in the middle, but you haven't used up all the numbers up here, and then you have to keep going as well. Okay, so let's go down to number 3. So I'm going to color, actually I'll write it and then I'll color code it. So when I have 0.75 divided by 15, this is going to look weird because 15 is the bigger number, but it's going to go on the outside. Because whatever number comes up first in our division problem goes inside the little division box, and the 15 goes on the outside. And then before I start, I'm going to put a decimal point here. So I have to go and start with the 0. Will 15 go into this 0? No. So I'm going to put a 0 up here. And then 0 times 15 is 0. Go ahead and subtract it just so my steps are there. And then I'm going to bring down the 7. Well, 15 won't go into 7 either. So after the decimal point, I'm going to put another 0. 0 times 15 is pretty easy. That's 0. I subtract again, get 7, and bring down the 5. 15 will go into 75, but that's one that we might not know off the top of our heads. So we can estimate a little bit. If I round 15 up to 20 and think of this as 80, I know it's around 4, maybe 3 or 4. What do you think? What do you want to try?
I'll say it goes into it 5 times.
5 times? Okay, so I was thinking 4. So I'm going to show you what this could look like if you don't know it and you are not allowed to use a calculator, because we will have to be able to do this without a calculator. So I was estimating, I made this 20 and this 80 in my head, and so I was estimating it would go in about 4 times. So I'm going to write out what 15 times 4 is. So if you think about time, 15 minutes times 4 would go all the way around the clock. Or I can write it out and I get 60. I think it's going to go in one more time. 15 times 5, 1 times 5 is 5 plus 2 is 75. So I was close. I didn't have to do a lot of practicing there. Give me just a second. And then 5 times 15 is 75, and I can show that we had no remainder. I've used up all the numbers, and so that's my answer. What did you?
I thought of 15 times 2 is 30, and 30 times 30 is...
Okay, so you were doubling, and that's another memory trick. So he was saying he took 15 times 2 is 30, and then he was thinking, okay, then that would make times 4 would be 60, and he did it that way. 15 is one that you can kind of think about time and think about 15 minutes going around the clock. You could come up with it. But I wanted to show you, what if this was 17 or some random number that we just don't work with as well? Just do a quick long division out here. Estimate how many times it's going to go in so that you don't have to go through 2 and 3 and 4 and 5 and all of them. But you may have to do a little work to the side, and that's okay. Let's look at number 4. So we'll scoot this over. So remember when we set this up, if you're going to write it from left to right, you can think of this as switching order. So I'm going to have 0.2 on the outside and 4.4 on the inside. So I'll color code that. The first number went on the inside, and the second number went on the outside. Okay, so this one is a special case. Because if you have a decimal out here, we don't do that. We're going to change that so that it's not a decimal. So this is how that works. I'm going to move this decimal place over 1 place and change that to 2. And I'm going to leave a little bit of space and rewrite it. But the rule is if I move the decimal over on this number, I have to move the decimal over 1 place on this number as well and change that to 44. So we might write a note in our notebooks that we're going to move the decimal to make it a whole number. When we do long division, we don't leave decimals on the outside. You move that decimal place over one place, so it's 2. But if you move this one, you also have to move this one. Otherwise, your decimal place will not be in the right place when we're done. Well, 44 divided by 2 looks like elementary school stuff. You can probably do that one in your head, but I'll go through the process. So 2 goes into 4, 2 times 2 is 4. We subtract and get 0. Bring down the other 4. 2 goes into 4, 2 times 2 is 4. We subtract, we get 0. And my answer is 22. So it looks really difficult when you have 0.2 and 4.4. You can make it easier by getting rid of those decimals. Okay, so we're going to practice that a little bit, and that's just a rule. If there's a decimal on the outside, we move it. But if you move this one, you have to move this one as well. It's an all or nothing deal. So any questions on that? All right, so let's look at another one. So let's go down here to number 5. So 0.4 is going to go on the outside, and we're going to put 1.7 on the inside. So I'll color code just how I set this up to start with. That went on the inside, and this went on the outside. And then the thing I want to check, it's okay if there's a decimal in here. We did some of those, that's fine. We just don't want a decimal here. So I'm going to move this decimal over one place, and if I put the decimal after the 4, that just makes it 4. And I'm going to leave a little space to work and write that. But if I move that decimal over one place, then I have to move this over one place, and that makes this 17. And we can tell that's not going to go in evenly like the last one did. So we'll go through that process. So will 4 go into 1? No, I'm going to skip that. Will 4 go into 17? Not evenly, but yes. How many times? Go ahead. 4 times. That's going in 4 times. Where does that 4 go up here? Jaden.
Above the 7.
Above the 7, because I'm not putting it into the 1. I'm putting it into 17. So it's going to be after that last digit. Then 4 times 4 is 16. I'm going to get a 1. Now, we're not going to write remainder 1 here. We're past that. We're going to add a decimal point. So after the 17, I'm going to put a decimal point, and I'm going to put 0.0. Because 17 and 17.0 are the same number. That makes that legal. If I put a decimal here, though, I need to put a decimal after the 4 up here. And the reason we're doing that is so we have a number to bring down, and I can make this down here 10. So how many times will 4 go into 10? Go ahead.
Twice.
2 times, so I'm going to put a 2 here. 2 times 4 is 8. I'm going to subtract and get 2. I'm still not done because it hasn't zeroed out. So I'm going to put another 0. 17.00 is still just 17. We didn't change the number at all. And I'm going to bring that down and make this 20. And finally, we're going to get to finish this because 4 goes into 20 evenly. How many times? Silas?
40. I mean, not 24.
5, right? Okay, there you go. 5 times 4 is 20. And then really quick, I'm going to put subtract 20 and the 0, because that's showing that we're done. We used all the numbers that were there, and we added some decimals. It's very important that you have that decimal point and the decimal point here. If I didn't have the decimal point, I'd be changing 17 into 170 and then 1,700, and that's not okay. But I can put 0.0 and 0.00, and that's okay. So 4.25 is the final answer on that one. Okay, so on number 6, I am going to be very careful with my space because I know, since I've done this before, that's going to take a lot of space. I'm going to set it up over here, and then I'm going to write out my long one over here because I'm going to need all of this space. So when I write this out, the 0.4 goes on the outside, and the 7.49 goes on the inside. And somebody last year, I don't remember who it was, told me that they just think of it as switching places. And that's not a bad way to think about it. when you go to write down long division, they do change order. All right, so I can't have 0.4 on the outside. So this is the number that matters that I have to change. So I'm going to change 0.4. I'm going to move the decimal over one place and make that 4. I'm going to write that over here where I have lots of room. And if I move this decimal over one place, I can only move this one over one place. So we're not going to change it to a whole number. It's going to change to 74.9. I just moved the decimal over one place. It's okay to have a decimal on the inside. It's on the outside. We don't want to work with decimals. We want to make this easy on ourselves. Okay, so how many times will 4 go into 7?
Once.
One time, good, because times 2 would be 8. So 1 times 4 is 4. We're going to subtract. 7 minus 4 is 3. Bring down the 4. So now I have to think about my times tables with 4. How many times can I take 4 into 34? Rabbit. 8 times. Good job. So I'm going to have it 8 here. This is still before the decimal point. 8 times 4 is 32. So 4 minus 2 is 2. And I'm going to bring down the 9. How many times will 4 go into 29? Silas. 7 times. Now look, I forgot to put a decimal point up here, but I know because I'm using that 9 after the decimal that this 7 needs to come after the decimal point. So 7 times 4 is 28. We'll get a 1. Bring down the 0. And it's gonna take us a little bit to finish this one. You make sure you're really neat in keeping things lined up. So now I've got 10 because I added a 0 because 0.90 and 0.9 are the same number. Okay, tell me how many times it'll go in. 2 times. So 4 is going to go into 10 2 times. 2 times 4 is 8. We subtract and get 2. I'm still not done. So I'm going to add another 0. We get 20. And that's finally going to go in evenly. 4 goes into 20 5 times. And this is a 2. I didn't write it very clearly. And 5 times 4 is 20. And I know I'm done when I get that 0 and everything divided evenly. Okay, so you're going to keep adding zeros after the decimal until it finishes today, and then we'll talk about repeating decimals later. Some of you know what I'm talking about. Question? Yes. So let's go down and look at a couple story problems and talk about when you're going to do division problems. It says a soda factory produced 7.82 liters of root beer in 2 minutes. How much root beer on average did the factory produce each minute? So 2 minutes, we made this much. They want to know how much it would be in 1 minute. So they want to know basically kind of a unit rate, how much per minute. So how would we set that up?
7.82 divided by 2.
Okay, so 7.82 divided by 2. We're going to divide this into those 2 minutes and figure out what was in each minute. So then when we set up our long division, I'm going to have 2 on the outside and 7.82 on the inside, and I'm not going to forget that decimal point up here. Alrighty, so we're going to see, will 2 go into 7? Yes. It'll go in 3 times. 3 times 2 is 6. We will subtract, so 7 minus 6 is 1. Bring down the 8. How many times does 2 go into 18? Let's let somebody else try. Go ahead. 9. So that 9, because the 8 came from after the decimal point, that 9 is going to go after the decimal point. 9 times 2 is 18. Sometimes people get confused because I'm getting 0 and they think we're done. Why am I not done on that problem? Silas. Because I still have the 2. I haven't brought everything down yet. Some of us get confused. So just because I got a 0 here doesn't mean I'm done. We weren't to the point of looking for a remainder yet. So now I'm going to bring down the 2, and now I've used up all the numbers that were up there. 2 goes into 2 1 time, and then I'll be done. So if I'm answering the question, how much root beer on average did the factory produce each minute, I probably ought to write this out with some labels. So this is how much root beer. How are we measuring the root beer? Okay, we were using minutes, but how are we measuring root beer in the bottles? Go ahead.
Liters.
Liters. So it wants to know how much root beer it was producing in a minute. So we're using liters and minutes. So our answer is going to be 3.91 liters per minute.
You forgot to finish off the problem.
Oh, I did. 1 times 2 is 2. We subtract and get 0. Thank you. My brain got stuck on the label. So that's how many liters they're producing per minute. So this is not a big soda factory. This is not like Coke or Pepsi. This might be, there are little companies that you can walk in and they'll have a little old-fashioned soda shop where they actually make their own soda. And so this would be, they're making root beer. They'd have a little machine and it's cranking out root beer. And they're not making like thousands of liters per minute. They're making like almost 2-liter bottles per minute, which is still quite a bit.
Like the people that come up for 4th of July, the group.
I don't know. Okay, so let's finish this. So number 8 says Kinji. It's a kind of a cool name. It sounds like a dog name to me. I think because Benji was a show when I was a kid. There's this dog, and you've probably never seen it, so that just makes me think of that. He used 466.8 gallons of water over the course of 5 days. It sounds like a lot, but in your house, it's probably not as much as you think if you're doing laundry and running a dishwasher and taking showers. And so it says, how much water did Kinji use on average each day? So if you're trying to figure out on average, so that's some key word. Let me highlight that. It was in both of these story problems. When you're seeing that key word on average, that is a word that lets you know you're going to do some dividing, because average is a word that we use for mean a lot. So he's already added up all of the gallons for the 5 days. You could have a problem where you have to do that first, add it up, and then divide by the number of days to find the mean, which we've talked about before. They just went ahead and did the adding for us, so all we have to do is divide. So we're going to take the 466.8 gallons. We're going to divide it over 5 days to see how much we're using each day. So I'm going to go up in this little space here because I know this one's going to take a little bit. There's a lot more digits. The 5 is going to go on the outside, and the 466.8 is going to go on the inside. Do I need to move my decimals at all on this?
No.
Why is this one okay? Go ahead.
Because there's no decimal.
Because there's no decimal on the outside. It's just 5. If this number is a whole number, we're good. Okay, so will 5 go into 4? No. You could put a 0 there if you want. Or we could just go 5 go into 46. Yes. How many times will it go into 46? Go for it. 9 times. So I'm going to put a 9 up here. Brian, do you want to tell me what 9 times 5 is?
45.
45. Good. 9 times 5 is 45. Since you had your hand up, I figured you knew that. So if I take 46 minus 45, I'm going to get 1. And then I'm going to bring down 16. So if we think about 5, so how many times will 5 go into 16? You want to do it?
3 times.
3 times. Good. And we're still before the decimal point. I forgot to bring that decimal point up. We're still before the decimal point because we're still using numbers over here before the decimal point. So 3 times 5 is 15. We subtract 6 minus 5 is 1. Bring down the 8. And I think we're going to use 3 again for 15 because I can't go another 5. That would give me 20. So 5 will go into 18 3 times. 3 times 5 is 15 again. We're going to get 3. And then I'm out of numbers, but I want to keep going until my decimal is either done or it's repeating. So I'm going to add a 0 because 0.8 and 0.80 are the same number. And I can bring this down and make it 30. You want to tell me what that would be?
The 5 will be go to 30 6 times.
6 times. And so the 6 is going to go out here. 6 times 5 is 30. And subtract to get 0. So 93.36 is how much water he's using every day. So what kind of a label am I going to put on my final answer? 93.36 what per what? Go for it.
Gallons per day.
Gallons per day. So I could abbreviate gallons, G-A-L, per day. And so on story problems, we should label because it's not like I'm using 93 milliliters, I'm not using 93 quarts, 93 cups. It's important that we know how much that is.